In Part B of Section 1, we're going to look at describing end behavior of polynomial functions. Excuse me. Now, you can have x squared, and we've been dealing with x squared and quadratics for a long time. So when your biggest degree, or your biggest exponent is 2, we call that degree 2, and that is going to be a parabola, which is either going to look like this if the x squared term is positive, or if the lead coefficient on the x squared is positive, or like this if it's negative. So that's with x squared, and we'll talk about end behavior with some of those things. If I have x cubed, so if I have x cubed, graphs for these are going to look something like this. So y equals x cubed, the base parent graph is something like this. Okay, y equals negative x cubed looks something like this. Okay, so as I go to the right with y equals x cubed, it's going up. As I go to the left, it's going down. Now, what's going to happen when you start to add the other terms on there, so maybe x squareds and x in the constant terms, sometimes your graph is going to look like this. So the key thing is if there's a positive number right here, so if this lead coefficient, I put a 1 there, but it could be any positive number, your graph is going to look something like this. And it might start to, go up and then come back down and go up. If it's negative, it might look like this. Okay, so that's a key thing. So it starts out in the upper left and goes to the lower right with negative x cubed. And that's key. And sometimes you can have, and we'll talk about graphing these in the next section. If you have x to the fourth, okay, so with x cubed, you always have opposite end behaviors. One side of the graph is going up, one side of the graph is going down. With x to the fourth, okay, you're going to get graphs that look something like this. The end behavior is going to be the same, either both up or both down, and it's all based on is this a positive or not. If it's positive x to the fourth, you could get graphs that look like this, almost like W-shaped, where it goes down, comes back up, goes down, comes back up. If it's negative x to the fourth, so in other words, some negative number in front of x to the fourth, it's going to be kind of a similar thing, but the end behavior is going to be going down. So these are just some general rules with graphing higher order functions, okay, and kind of some general shapes. So we'll talk about describing the end behavior here on 25. If you notice on 25, our biggest, we call that a degree 2. So the biggest exponent is 2. So the degree is 2. And our lead coefficient, so in other words, what's on the x squared is negative. So what that means is if it's x squared, degree 2, it's a parabola, it's going to look something like this. And we're just going to draw a general sketch. Now, to describe the end behavior, we have to use correct notation. And this gets a little used to, takes a little time to get used to. So if it's negative x squared, it's going to look something like this. So we're going to describe the end behavior here on this side right here. So as I go, if I had the x and y axis on here, as I go to negative infinity with the x, what's the function doing? Well, it's going down. Okay, so f of x, which is the function, so what's this end of the function doing right here? It's going down. F of x goes to negative infinity, because this would be negative infinity in the y direction, as x goes to negative infinity. So as we go to negative infinity with our x, this is going down. Okay, now let's describe the right side. So that would be this side. Well, as we go to positive infinity on x, what's f of x doing? It's going down towards negative infinity. So f of x is going to negative infinity in the y direction as x goes to positive infinity. So as I go infinitely out here to x values, this graph is going down towards negative infinity.